Hi, everybody. I got word from Mrs. Merkel that you guys were having some difficulty with some of the reactions. And I was told to go over a couple of things. Number one was, how do you balance oxidation numbers? I got to admit, I was kind of surprised to get asked this question because that's something that we did back in October. So let me just try and refresh your memory. And I'm going to do that with my synthesis reactions here. Okay, so let's say we've got this reaction, calcium and oxygen. Okay, so calcium plus O2. Now, if I look at my oxidation numbers, calcium is in the second column of the periodic table. So that means it's automatically got a +2 oxidation number. Oxygen, on the other hand, has a -2 because it's in that second to last column before the noble gases. It needs basically 2 electrons, so it's going to be -2. So if calcium is +2 and oxygen is -2, we need one of each. So my formula is going to be CaO. Now, I then have to go and see if my equation is balanced, and it isn't. I've got 2 oxygens in my reactant, but only 1 in my product. So I have to put a 2 in front of my CaO. So now I have 2 oxygens on both sides. I also now have 2 calciums in my product. So that means I have to put a 2 in front of my calcium in my reactant. And now it's balanced. Okay, let's try another one. Let's go down here to number 5. Silver plus sulfur. That's going to form silver sulfide. Now, silver was one of the ones you had to memorize, and silver has a +1 oxidation number. Sulfur is in the same family as oxygen, so it is -2. That means I'm going to need 2 silvers, I don't know what's going on there. It's not allowing me to do my subscript. Two silvers. Oh, I just love technology. And 1 sulfur. So I need 2 silvers to balance it out. Okay, so hopefully that's refreshed your memory. One other question that I got asked that Mrs. Merkel told me you had was, how does the subscript affect the oxidation number? Remember, it doesn't. Subscripts are part of the name. So NO3 is always going to be NO3, and it will always have the charge of -1. Okay, so let's go over some of these single displacements. I was asked a little bit about the single displacements. So let's look at this first one. Silver plus potassium nitrate. Now, first of all, I want to remind you that the cations switch places. So my positive ion is going to switch with my positive ion. So I can't form silver and potassium together. Those are 2 positive ions, and they don't work together. Okay, so that can never be. So silver is going to want to switch places with potassium. Now, whether it does or not depends on where silver is relative to potassium over here on my activity series. And if we look, let me move me out of the way, silver is really far down and potassium is really far up. Silver is not strong enough to kick potassium out of that compound. So therefore, there's going to be no reaction. Now, let's take a look at this next one. Aluminum plus H2SO4. Aluminum is over here. Aluminum is kind of in the middle, but it's still a lot higher than hydrogen. So, aluminum is going to be able to kick hydrogen out of that compound. Now, aluminum, we remember, is +3. That was one of the ones you had to memorize. SO4 is -2. So, I'm going to have aluminum, Al. Let's see if I can get a subscript here. Yes. Al2 SO4 3 plus H 2. Okay. Why is it H2? Hydrogen is one of the 7 that we said will always be diatomics, that will never be alone. Okay, that's hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. So now we have to check and see if we're balanced. I've got 2 aluminums in my product, so I need 2 aluminums in my reactant. I've got 3 sulfates, so that means I need 3 in my reactant as well. And now I've got 3 times 2 is 6 hydrogens, so I need 3 times 2 is 6 hydrogens in my product. Okay? All right, I hope that's helped you with the single displacements. Now let me switch over to my second page. And here we can go over some of the double displacements. Okay? So here's my first one. K2S potassium sulfide plus silver nitrate yields. Now in a double displacement, like the single, the cations are going to switch places. So potassium's going to go with nitrate and silver's going to go with sulfide. Okay, so I'm going to first write my formula for potassium nitrate. Potassium is in the first column of the periodic table, so it's +1. Nitrate, one of the ones you had to remember, is -1. So that's KNO 3. Oh, that's a 2. 3. 3. Now, before I go on, I have to decide if that's going to be a precipitate or not. If I look on my table, it says all nitrates are soluble. So it's going to be AQ, aqueous, or in solution. Now I'm going to form silver sulfide. Silver, if you remember from our previous page, is +1. Sulfide is -2. So we're going to need 2 silvers to balance out my sulfur. So now I'm going to look and see, is this going to be a precipitate? Well, here's my sulfate. It says all sulfides are insoluble except sodium, potassium, ammonia, and magnesium, calcium, strontium, and barium. So silver is not one of those. So that means it is going to be a solid. And that's my reaction. Now I have to go and see, are we balanced? Well, I can see right away that we're not, because we have 2 potassiums in my reactant and only 1 in my product. So I have to put a 2 in front of my KNO3. Now I've got 2 potassiums here, 2 potassiums here. 1 sulfur, 1 sulfur. 1 silver, 2 silvers here. So I put a 2 in front of that compound, and that will help me make my nitrogen and oxygen be balanced. Okay. So hopefully this has helped a bit. I'll be back after the break. I'm not going to quiz you before that. Go back over, make the corrections that you need. Okay? Again, if you have any problems, shoot me an email. We'll see if we can sort it out. Have a great rest of the day.